All right. Hello, everyone. Welcome back. So it's CS596 machine learning. And so today, as the second lecture after the introduction in the previous one, we're going to talk about how to set up the necessary programming tools, programming environments that will be used in this course. I have uploaded the slides, and if it's the first time that you try to set up Python and also try to install all the necessary packages, it might be a little confusing at the beginning, but it's okay. And Python itself alone is not one of the easiest software package to have a very nice clean dependencies that are easy to deal with. So everything from Python, we have several ways even to install the same package. So there's a lot of messy stuff going on, but today, based on my previous experience from all the students and all my own experience installing Python on different platforms, I will try to have a brief tutorial that is easy to start with for you guys. And also, besides installing the software, I also have, as a second part for the lecture today, I'm going to go through some language specificities, some language grammars about Python that are useful, particularly useful in the scope of machine learning course, okay? And particularly importantly, we will talk a bit about a third-party package in Python called Numpy. And Numpy will be the package that we heavily use for basically all the assignments in this course. Okay. All right, let's get started with Python first. So it's about installing Python first. So unfortunately, I don't have a Windows computer at my hand. So my own experience are mostly based on Mac and Linux. But I think nowadays we have a pretty much integrated environment called Anaconda. That provides a very consistent solution to all three kinds of platforms, including Windows, Mac, and Linux. Okay, and the screenshot I have here in the following slides for Windows are from a year ago or even maybe 1.5 years ago. So it's not the most up-to-date Python installer for Python. So it might be some inconsistency with the Python that you will see on your Windows machine. Okay, so can download the Python from the official websites. So one thing about Python is Python 3 and Python 2. So we will use Python 3 in this course. So please make sure that you don't use Python 2 for the programming task, for all the programming assignments, programming tasks in this course. Okay. So let's go on to the page for Windows first. So it usually comes with the binary installer that you can download here and choose whatever binary package that fits your system and go to the steps for installing Python. And I think in Windows installer, there is a step that you need to check when you install Python, which is to install launcher for all users. I think that is recommended. And also add Python to path. to pass, which is a system environment variable. So please check these two boxes. I don't particularly recall why I emphasize that I need to check the first box, but the second box is important because after you add Python, the install Python to the path, you are able to call it, or you're able to use it in command line tools. So on Windows, it should be the CMD window or PowerShell window, whatever shell you use. So in command line, you're able to call Python. So that's, and also call Jupyter Notebook, which will be later introduced. Okay, so that is the installing step for Windows. And there's another option which you need to click, which is to disable path length limit. Okay, I think that is also important, but I don't know whether this option is still here for the latest Python 3.8. Okay, please, if you have different, if you have seen different conditions in your case, please let me know. Yeah.
Can we do the most recent version of Python or no?
I would recommend at least Python 3.7, and 3.8 is also fine. But for the, I think 3.9 is still in beta. I don't recommend you to use a beta version Python. Yeah.
So only use up to 3.8. Don't use 3.9.
Yes. For
Okay.
the most secure solution, I would use 3.8 or 3.7. I think both 3.8 or 3.7 should work.
They have like 3.8.
2.8?
No, 3.8.6. So what about after 8? Does it matter?
I didn't get your last question.
So there's like 3.81, 3.82, 3.83.
Yeah, the last digit doesn't really matter a lot.
Okay.
Yeah. 3.8 point X, let's say. Yeah. Okay, so after you have successfully installed Python, you should be able to launch this IDLE Python shell in Windows system from your start menu. So you will see a prompt for entering Python code like this. So this is something in Windows you can see. And if at this step, that means you're pretty much set up for the Python environment. Okay. All right, that's for Windows. So for anyone who use Mac or Linux, these two systems provide a default Python, which is not recommended to use. So if you're a Mac user, I would recommend you use this package manager called Homebrew to install Python. And so it basically, you can install it by typing the commands in your terminal. And if you are a Linux user, then it also comes with default Pythons. But I would recommend you not to upgrade the default one. Upgrading default packages in Linux is usually very risky. So I would recommend you not to download the packages on the official website and follow the steps to install Python 3.7 or 8 on your Linux. Okay. So lastly, although you have been as shown in the previous few slides, by installing Python as a software alone, I would recommend that Anaconda can be used as a integrated distribution. Okay, so after you, this is a screenshot from Mac, but I think in Windows it should be more or less the same thing that you will see if you integrate, if you install through Anaconda. So Anaconda is a very large software package that includes not just Python, but also some of the core packages that will be very oftenly used, such as Numpy, Pandas. So those core packages are also included. So after you click through the Anaconda installation, you will basically have everything ready to carry out the most commonly used, the most common data science tasks, including machine learning tasks. Okay, that's Anaconda. All right, so until this page, we were talking about installing Python. Okay, so Python is a programming language and a programming environment that allow you to install a couple of third-party packages. So from the next slide on, I'm going to show how you can install some of the key packages that will be used in this course. So for Mac and Linux user, you can install packages by opening your terminal window and typing pip install. So this pip is a package manager for Python. Okay, so after you have installed Python, you can find pip on your system and you pip install. So this -u is for upgrade. If you already have Numpy, it will upgrade Numpy for you. So you can install Numpy and Jupyter. So Jupyter is a package that provides the Jupyter Notebook that all of our assignments will be based on. Yeah, so these two packages are necessary. You need to install them successfully on your system. Okay. So if it's this step, pip install step is successfully done, then after that you can type in Jupyter or type in IPython in your notebook, in your terminal. You will see something prompt out like that. So this is a Python interpreter or Python, or what we call it's REPL, REPL interface for Python, in which you can type in Python commands and it will execute the code for you. Okay? So this is for Mac and Linux. And the way for installing Numpy and Jupyter in Windows, I think if you type pip install Numpy and Jupyter, it should do the job for you in Windows. Okay, but since some of the in the last slide, I recommend that you can install Anaconda on Windows to provide an integrated solution to everything, including Numpy and the Jupyter. I think after you have installed Anaconda, you don't need to install Numpy and Jupyter again. Okay.
And will you need to update them in the same way that you did there with the -u, or will it be up to date as well?
These updates are not necessary. I think all the code in the assignments, they are pretty compatible to older versions of Numpy and Jupyter. There's nothing that's really new, really fancy.
Okay, good deal. Thank you.
Yeah. What about Windows 10? I think I have tried Windows 10. So all the screenshots that I shown before here are for Windows 10, where I got from Windows 10, I think. Yeah.
Yeah, it was what I saw earlier.
Yeah. pip install command works on Windows 10. Okay, all right, good. It's good news. Installing with Anaconda is easiest for Windows. Yeah, I'd agree. I would agree with that. Yeah. Okay. I see some of you are doing the real-time experiments here. That's nice. Okay. All right, I think that's a good way of interactively spot any possible errors in the process of installing Python. Yeah.
You work on command line? Yeah.
I like this way of problem solving. Okay, so assume that you have installed the Jupyter and Numpy. Then you will need to go to a local folder in command line. Okay, so this line here is what you type in your local command line. So this dollar symbol is something you don't need to do. You don't need to you don't need to type. So this is a command line not for Windows. Okay, so this is for Mac and Linux. So in Windows, well, is it CD? I don't remember. Is it dir or CD? I think in Windows command line, it should also be CD, right? So the CD here is for change directory. So you need to go to the directory that contains a folder or whatever folder you would like to have for a certain assignment or a certain lecture. So for example, I go to my home folder, I go to projects, CS596, and I made a folder called lecture 2. And in lecture 2 here, I will type Jupyter Notebook, Jupyter-Notebook. Or if you also installed Jupyter Lab, which are a slightly different thing than Jupyter Notebook, it will open a browser like this. Okay. And that means you are correctly set up for Jupyter Notebook. Let me see if I can share my command line and show a complete example here. Oops. Okay. All right, let me stop sharing the current slides and share my command line.
You get it?
Okay. So I'm here in my, let me use a smaller window, in my home directory. So I can enter any folder that I would like. Okay. So I can go to my documents, right? So here, if I type, so I already have Jupyter Notebook installed. So if I type Jupyter Notebook, it should open up something like a browser. It's taking a while for the first time. Better run this one. All right. So after all this code show up, okay. So you see a bunch of code running here. Then that means a browser window has already opened. And then let me see if I can share another screen.
After we install that package, did it make the Jupyter folder in our directory, or do we have to make it ourselves?
You don't need to make a Jupyter directory. So after you install the Jupyter, that Jupyter goes into the default where all the Python packages are located. So you don't need to. So when you are creating a folder in your command line, you don't need to type anything related to Jupyter. It can be an arbitrary name. Is that what your question is about?
I'm just not sure. Like, do you know if I guess you could say that command that you just ran runs the same on Windows?
I think so. I think so. So let me share another window again. Now I have opened up my Jupyter Notebook in Firefox. So after you typed Jupyter in your command line, it should show you something like this. So as you notice that this folder contains this view in the browser view contains everything in the folder where I stop or where I start the Jupyter Notebook. Okay, so right here I can do something like files. I can new a Python interpreter, Python 3 or Python 3.7. Okay, so let me create a new Python 3.37 Jupyter Notebook. Okay, so this Jupyter Notebook is a newly created. It's an untitled one, so I can rename it by clicking the name like demo and rename. Okay, so it shows demo. So here, if you look at this line of text box, it's called a cell. Okay, so this is called a cell. A cell is where you can input any Python code to be executed. Okay, for example, I can import numpy as np, and in this cell you can have multiple lines, right? You can import os, import anything else. But right now, after you have imported numpy, then you can do anything you would like to do with numpy. Say you can define some vectors by numpy. Let's do one code here. One line of code here. Yeah. So with this line of code, I haven't executed yet. So I can click on this run, or I can click on Shift Enter. So it's executed. Okay. So now the numpy package is imported to your current notebook, and it's renamed as np just for short. Okay. So I think you can compute, you can print the version of numpy, maybe in this way, yeah, and execute the second cell. It shows it's 18.5. It's success. It's already there in your system. So as you can see that I have executed 2 cells in the Jupyter Notebook already. Okay, and now if I save you can like use Command S or Control S in your Jupyter Notebook to save the notebook any time you would like. Okay, and in a cell you can do basically anything else you usually do in numpy. To any Python code can be executed by a numpy cell here, right? And also after this third cell is like executed, and the output is shown here. And you would like to clean the outputs. I think you can click on cell and current outputs, clear. Okay, and you can also clear all the outputs, clear. Okay. And you can basically write any code that you like. Right, so you can think of each cell as an environment that you can define variables and write code, write logics, and execute code. And the variables defined in each cell are kind of shared between cells. Like here, I define for example, let me go to a new cell. I can define a vector in, let me see if I can increase the, that should look bigger, right? Zoom in a little bit. So I can for example, I can define a variable called A, which is a vector, Numpy vector that contains all ones, which has 5 elements in it, and then I can access this variable in the different shell, right? It looks like this. I can access the variables defined in the previous shell in the other cells. Okay, so basically,
I got a couple of questions about this.
Yeah.
Would it recognize A if you had that line above it? So say if in line 6, where you say print A, if you had that in line 5, would it still recognize if those two were swapped positions? Or do you have to define the variable before you access it?
Yeah, that's a good question. So we need to define a variable before we access it. So
Okay.
Right now, if I go to this empty line, if I print anything that I didn't define, right? We didn't define B yet, so it'll be a problem.
Okay.
It
And
comes out
then,
name B is not defined. Yeah.
Is that running instantaneously, or do they like depend on one another? So like, could you define? Never mind. It's okay.
Yeah. So this line of code, for example, it depends on NP. If this line of code is not imported, and I directly call NP, then it will be an error. But since we already imported NumPy as NP, then this line of code is valid.
Hello, Professor.
Yeah.
I have a quick question. I'm curious why this line number before 4 is not showing, like 1, 2, 3 is not, from 4 is showing. What's the reason?
Oh, because I cleared all the outputs before.
Oh, that is the reason. Okay, got it.
Yeah.
Thank you.
Yeah. So by clearing all the outputs, so all the outputs are gone now, but that doesn't mean all the variables are gone. The variables are still in memory. You can still print it. And the index here becomes 9 because the internal counter is still there. You didn't wipe out all the memory. You just have the view cleaned. But all the internal variables are still in Python. It's still running. It's still in the backend Jupyter Notebook. Okay.
Got it. Thank you.
Yeah. So you can actually use kernel to restart and clear outputs. So we can like click on this, restart and clear outputs. So it gives us a warning because we are going to clear everything, wipe everything totally from memory. So then this is a plain plain notebook that didn't have anything. So if we click on print A, it'll be an error because A is not defined yet. If we click on this one, then it also gives an error because NP is not defined yet. we have to go sequentially from the top, from the very beginning by importing Numpy, right? And then this one will be correct. Yeah. So I see some talk, some chat history. Let me see if there's a problem, question here. Own directory. Yeah, you need to have your own directory. I already have a PyCharm. If I already have a PyCharm, anything special I need to do to install? PyCharm is a separate IDE that is not related to Anaconda. Anaconda is a it provides programming environment. It provides packages for you, but it's two things from the PyCharm. Will the installation of Anaconda affect PyCharm? I didn't try that. I don't think there should be a visible negative impact, but I'm not sure. If you use Anaconda open. Yeah, good points. On Windows, you need to, if you use Anaconda open command from the navigator, install from there. That's some good tutorials. Okay. Let me go back to the slide for now. Okay, let's finish the remaining parts. All right, so here is something that I just demoed in Python 3 in a Jupyter Notebook window.
Can you show us how to do that again? It's kind of moving a little fast. How to make the notebook?
Here?
Yeah.
Yeah. So at which step are you now? Are you in now?
I've barely opened up Jupyter from the command line.
Yeah.
And it says that the notebook list is empty.
Yeah. Are you able to create a new notebook? So maybe I can
Look at Python 3.
Let me switch back again. So are you currently here? So there's a new button here.
Okay.
Yeah. So there's a new button here. So and you click on Python 3 or whichever Python you have, and it will show up as a empty notebook.
Is it okay if see like but the Python I installed doesn't come up, but Python 3 comes up? Is that okay?
That's okay. Yeah, I think you can try it.
Okay.
All right. Yeah, let me showcase another usage. Okay, so right now this notebook is called demo. Let me just rename it as assignment 1. Just assume that, let's pretend this is our first assignment. Okay, assignment 1, and it's already saved. Then I can shut the notebook. Okay, I can quit. Okay, you have shut down notebook. You can now close the tab. Okay, in order to use it again, you need to relaunch it. Okay, so now we'll going back to my command line to show how to launch the existing notebook. Okay, so as you can see, this is my command line, which I used to launch the Jupyter Notebook, right? So if I list all the notebook files here, I can see something called Untitled IPYNB, And the second file is called assignment1.ipynb. And this assignment1.ipynb is the one we're going to use. So I think we're going to start here by calling Jupyter Notebook. And it will launch let me going back to the newly launched. Is it Safari or let me double check. Oh, this time in Safari. Okay. Yeah, it doesn't matter which browser you are using actually. So, okay, now I have launched the Jupyter Notebook. So now I'm going to click. Did you see this? See this assignment one? This is the one that we saved before. Okay, if I click on it, it opens up the notebook for us. Yeah, that is exactly how we open all the assignments notebook files. So for the assignments, I'm going to provide an existing Jupyter Notebook file to you. You can download it from Canvas, and after you have downloaded the notebook, you should save it. Save it locally, and then you go to command line and launch the Jupyter Notebook and click on it. It will open up, and you will see whatever code in there, and you just follow all the code and accomplish all the tasks. Okay, so that's the example here, and I'm gonna.
I got a question.
Yeah, please go.
I noticed that like you have a lot of lines that say "in" with the brackets.
A lot of lines of what?
Does it go into like another line, I guess you could say, or it does go into another line, but it doesn't give me like another "in." I don't know what to call it. Like so I typed in import numpty as np.
Yes.
Enter, and it kind of doesn't give me another, like, you know how it says in square brackets and then semicolon. It doesn't give me that.
Yeah, you don't need a semi. If you want to execute one cell, you need to use shift command, shift return to execute that cell, and only after you execute one cell, it will create a new cell for you.
Okay.
When you press that run button, does it run all of the cells, or does it basically do what pressing shift enter does?
It basically executes one cell.
Okay, cool.
Yeah.
What's a shell? I haven't really used Python that much.
So that line of text code, that line of text box is called a cell in Jupyter Notebook.
Okay.
All right. Okay, so let's see what we can do here. Yeah, this is what I showed before. Okay, so that's Python setup and the Jupyter setup so far. So now let's spend some time on the Python language and all the other packages that we will rely on. Okay. All right. So it's something that worth your attention and your maybe a review after the class is over. You can find all kinds of tutorials that are online to help you to accomplish the first assignments. So the first assignment is to help you get familiar with Python and Numpy packages. Okay. So we'll go through the variables, assignments, built-in data types, common operators on built-in types, and simple control flow real quickly. Okay. So variables are those names to hold data. Okay, and the names are unique. So the same name refers to the same place in memory to hold a piece of data. Okay, and the assignment statements in Python is to use the equal symbol. Basically, you can use the equal statement, the assignment statement, to assign some data to some variables as its value. Okay, So that is the basic operation we will need to use. For example, these codes are what we use for using the Python built-in types. Okay, if in Python we type a equals 10, that means we create a variable with a name called a, and in that a variable we store some integer number which has a value of 10. Okay, and with a and b defined, we can compute c by plussing these two together. And the S1, S2, S3 here are a special of type of data in Python, which is called string. Okay, the first string he and the second string likes can be concatenated using the plus, just like we are plussing two integers. So this is the advantage of Python as a higher level programming language. Okay, and also you should follow some conventions that are generally followed in Python. Like you basically want to start a variable name with letter or underscore, and if there are many consistent letters, if there are many multiple letters in one score, you can use underscore to like connect them. And also case is sensitive in Python, so these are all different variables in Python. Okay, that's something about variable. And in Python, you can check the types of variables by typing the type or type of. It should be type of in Python to look at the types of the data. Okay, so let's look at some built-in data types in Python. Integers are numbers, integer numbers, and the floating numbers are the real numbers that comes with decimals. Booleans and strings, these are all most commonly used Python variables. So if you have previous experience programming Python, these should be pretty familiar to you. Okay, so a good thing with Python string, which also makes Python a strong and very broadly used programming language, is its very good support to Unicode. So all the string objects in Python, they follow the Unicode encoding schema, which means we can handling languages in different languages in the world easily. Okay, you can put different languages, multiple languages together without causing any problem. Okay, and this concept is something we're gonna look at here, which is called mutable and immutable. So if a variable can be modified in place, then it is something called mutable. It can be muted. If something is not immutable, then we cannot modify it in place. And in Python, we want to particularly pay attention to several types of immutable objects. So first of all, list is a sequence of objects. It's similar to the concepts in other programming languages like array. Okay, so it's a sequence of objects, and those objects can be different types. So in the list 3 here, I put like 3 strings with an integer number into the list. Okay, so it's quite flexible data structure that allows you to put different types of things together. And the list is immutable. So after you create a list, you can enlarge it by appending elements into it, or you can removing elements from it. Okay, and there is a second data type called tuple or tuple. It's an immutable object. Okay, for example, after you have defined the tuples here, you cannot call append on it just like you did for a list. Okay, so the tuples, they are immutable. So they are often used to hold constants. Okay, so that's mutable versus immutable distinguishments in Python. Okay, all right.
Can you make a standard variable immutable too? So if you just had one, like if it wasn't a list, so if you just had the number 5, but you didn't want it to ever change, could you make it a constant?
So I think so 5 is like how do I say? So if you want to store, you store an integer number 5 into a variable called a, then of course you can change the value of a.
Right.
Right. But 5 itself is a constant.
Like, how do you make a variable a constant?
Exactly. That's what I'm asking. Yeah. So if it's just one variable, not a list of variables.
That depends on. That's not a common practice in Python. I don't think Python has a keyword for constant. Yeah, so constant is not a supported keyword in Python. So I don't think Python supports such a function.
So would you
Interesting.
people
Yeah,
add 5 to it?
interesting question though. Import constants. Oh, that's some very advanced tricks here.
I had a question about immutable objects though. Could you just replace a value in the tuple, or is it just that it can't have additional values added onto it?
Yeah, so after you create a tuple, you cannot replace any item in it, but you can totally assign a different constant to that variable called tuple1. So after you have
can overwrite tuple1, but you can't change any element in tuple1.
Right, correctly. Yeah.
Okay.
Yeah, that's correct. Yeah.
So how would you do that? Would you just have one line say tuple1 and then follow that up with another line that says that exact same thing, tuple1 equals?
Yes.
Okay, cool.
All right, let's look at some common operations. So first of all, computation, numeric computations, adding, subtracting, multiplying, dividing, these are all usable in Python. You can go ahead and try everything you would like to try. And the one thing I would like to bring into your attention is the floored quotient for between two integer numbers. And if you want to see what is the floored number, you should use this double slash, not the single slash. So in single slash in Python, it will automatically convert the result into a float number, into a real number. Okay, so that could be something different from other programming languages. And the double star to compute the power is something that can be sometimes useful in some of the assignments here. Okay, so this is a built-in operations for the Python built-in types. These are the comparisons and Boolean operations, or, and, not. Okay. All right. So I'm gonna skip this. So, and I'm going to talk about the list, string, and tuple here again in this slide. And there's some very easy to use syntactic sugars in Python, which means a convenient way to do some complex tasks in Python. So for example, you can check whether an item or an element is already in the list or in the string or tuple by using the in keyword. And also the not in. If you combine not and in, it just checks whether that elements do the opposite judgments. Okay. And also concatenation is easily done using the plus symbol. And the length function is also frequently used. And let's talk about the how to access elements in Python. So you basically use square brackets in Python. The first elements use the index 0. Okay, so the first element you should use something like S0. And so the last element is the length -1. Okay, and for length -1, there is a shortened usage just using -1 and -2. Just is a short form for length of S -1. Okay, so these are something quite convenient in provided by Python. All right, so
does that mean that it couldn't have arrays of negative values? They would have to be like from a positive to a positive?
Right, correct. The index
Okay.
can be a negative number. Yes.
Okay, cool.
All right. So based on this indexing mechanism, we can use this mechanism to get a slice of elements from a Python list. All right. So for example, in a slice, I column j, right, from I to j, it means we want to take a slice from the index I to index j, but we need to notice that the index I is included, but the ending index j is not included. So this is something special about Python language. Say, if you given the list here that contains 5 elements, if you use 0, column 3 to index to get a slice, it will get the elements from index 0, right, index 1, and index 2, which returns the elements 1, 2, 3. But the index 3 elements, which is 4, is not returned by this slicing operation. Okay, and also if you use 1 to 4, it will return the elements in here 2, 3, and 4, but the elements with index 4 is not included. So the ending is not included. So that is something specific to the language. Okay. Yeah, that's something you will need to pay attention at the beginning. But as you use this language more and more, you will get quite familiar with it. All right. So if you don't put the ending, it's actually just include everything in the slice, everything until the end. Yeah. And other functions like appendix, counts are all very convenient built-in operations. So let me see if I can reach the Numpy package for now. All right, sorted. I think it's quite self-explanatory. Splits, yeah. Upper and lower, these are for strings. Okay, I think I'm gonna skip the and also string is an immutable variable. Okay, it cannot be changed. It can only be overridden. Okay. Common operations on string. I think I'll leave these slides for your exploration. I think the coming slides for Numpy are more important to cover here. Okay, replace, I was skipped. And if else, yeah, if else, I would mention it a bit. So the if else in now in Python, you just need to pay attention to the elif. Okay, so it's just a shorthand for else if. Okay, we usually write if, elif, else, something like that. Okay. Iteration, yeah, for loops. For loops, we usually combine for loops with the in keyword, right? So this loop counter can be an arbitrary name. Anyone talking?
Oh. Huh?
There's some echoes.
Oh, I'm in class right now.
Isaiah, mute yourself.
Yeah.
I didn't know it was on, sorry.
All right, that happens. Okay. The for loops, yeah. I think I showed an example before in the notebook. It's a commonly used structure. Basically, you can use a for loop to iterate over any sequence like string, tuple, list, and so on. Okay. And there's some common usage about the range function. Range function is built-in function in Python that defines the starting, the ending, and the step for a for loop. It's very commonly used. Okay. So the for loops may be a little bit different from other languages like Java or C. But I think also the newer version of Java also implements something inspired by Python here. All right. Iterate over the first and the last and. Okay. I'll leave it for your exploration, the numerator. So the numerator will return, if you wrap numerator around a sequence, and as a result of the for loop, it will return two things, not just the elements, but also the index of the elements. So for example, here you can return the first word and the index 0 as well, so that you can access the word right after it, use I+1, because I is the index corresponding to the word W. Yeah, these are our convenience usage for using the enumerator. Okay. Yeah, so I would like to talk about these parts, Numpy basics. So Numpy is a package for numerical computing in Python, and it has a pretty long history. I think the first version, it dates back to 1990s, where people implement this package with a mixture of Python, C, and Fortran as backend implementations for very efficient implementation of numeric computing. So the default way in Python to handle large amount of numeric computing is very inefficient. So Numpy alone, this third-party package provides much more efficient implementations. So it's almost nowadays a common standards provides standards for data science, machine learning, and statistics throughout all these fields of computation those fields that heavily rely on numerical computations. Okay, so it has advantages over the built-in types in Python. For example, in Python, we'll deal with list a lot, but actually in this course, except for the first assignments, we are going to use the data structure provided in Numpy, which is called a Numpy array, instead of lists to store most of the data that are related to machine learning tasks. For example, the training data. When we have a bunch of training data, including images, including languages data, we will need to convert them into numbers. But those numbers are not efficiently stored in Python list, but they are more efficiently handled by Numpy array. So we will need to use Numpy to help us store the data. And also, Numpy provides very performance computing between those vectors, between matrices. These are the core functions we need to use quite a lot, almost throughout the whole course for the computation about vectors and matrices. Okay, and yeah, they have built-in support to linear algebra. So a lot of the concepts later we're going to mention. For example, when we do principal component analysis, we need to find the eigenvectors, for example, which is a concept in linear algebra. But in Python, we don't have such a function, so we'll need to heavily rely on those packages. All right. So in Numpy, the way you use it is to import it and rename it as NP. That is not necessary, but people usually do that because it's so oftenly called that you don't want to type in 5 letters. So you can just type 2 letters instead of 5. And the data structure, the basic data structure in Numpy is called Numpy, or ND is called array or ND array. And the ND is for n-dimensional. So this array can be of very high dimensions. It can have more than 3 dimensions. It can be 4 dimensions. It can be a matrix, a cube, and can have higher dimension than cubes. Okay, so in this particular example, we initialize a vector. It's a one-dimensional vector that has 4 elements in it. So if we print it, it will show a vector just like as if it's a list. Okay, but it's different than a list. And the type of it is not a list, but it's a numpy.nd array here. Okay, and with the nd array, we can do a lot of things. So it's designed to support vectorized operations. Okay, while Python list is not supported by it doesn't support that function at all. So for example, if you define a nd array here, and you print and you can add a constant 2 to the nd array. So all the elements will increment by 2. So this type of operation is called a broadcast. It's called a vectorized broadcast. Okay, so you don't need to use a for loop to iterate over all elements and add 2, increment by 2 to each element. So you can directly call this plus with a constant. So this is automatically done. But if you defined a list in Python here with the same elements and you call +2, it will be an error because Python doesn't support such a broadcasting operation. Okay, so that's just one simple demo for what Numpy can do. Okay, now let's look at something more complex than a 1D array. So if we have 2 dimensions, so it's we can basically think of it as a matrix. Okay, we can initialize a 2D array from a 2D list. Okay, but then this is just for a demonstration. In real world applications, we don't actually need to manually initialize a vector like this, initialize a matrix like this. Okay, so if you look at this 2-dimensional Numpy array, it will have a shape like this. So it's organized by a row style, and basically you can access the elements in each in this 2x2 in this 3x3 2-dimensional matrix using the square brackets and with correct indices. Okay, so this 0, 0 actually means that you want to fetch the elements in the first row and first column. Okay, so this means first row and this means first column. And if you use a comma and column, which means you will take everything in the first row. Okay, so this column in the second dimension means that I will take all the columns. Okay, and you can also put a column as the first dimension, which means you take all the rows, but within the first column. Okay, so this 147 is simply you take the result of taking the first column out and flatten it as if it's a row. Okay, so this is something you can play around with, and in the first assignments that I will release today, you will see some practices for you to explore with. Okay, so that's about Numpy 2D arrays. We have 8 more slides to go. All right, so with Numpy, we can do a lot of very fast vectorized computation. Okay, we can call summation. Okay, we can call summation over axes. So in Numpy, we use the term axis instead of dimension to refer to the concept of dimension. And if you define a 3x3 two-dimensional array here, you can sum up all the elements. If you don't provide any argument to the sum function, you will have the total summation of all elements. But if you provide a 0 here, it will reduce the first dimension by basically summing up all the numbers in that column and reducing all the rows. Okay, so this argument provided here is the axis to be reduced. So here, because the first axis is to be reduced, so these three numbers will be summed up together, which gives 12, right? And these three numbers will be reduced and the sum up to 15, and so on. Okay, so this is the particular type of action that we will need to learn to use basically throughout all the assignment works, in especially the beginning assignments. And if you reduce the column here, if you reduce the second dimension, you will basically sum up over all the columns. Okay.
Professor?
Yeah.
So then if you had a three-dimensional array, it would be a dot sum 2, right? That's just the dimension that's right that you're inputting.
Which line of code here?
No, the one you just worked out. I said, so if it was a three-dimensional array, then it'd be a dot sum 2.
Yeah,
right?
yeah.
Okay.
Right, correct. That's correct. Yeah. So there's tons of details. I don't think I will be able to cover all the details in one a simple lecture today. But I do wish to highlight some tricks you are going to use in the future, right? For example, this keeping dimensionality function, which is provided by this keep dims arguments. If you explicitly let it to be true, so the default value is false, I think. So if you explicitly to keep the dimensions, the result if you look at it closely, you see there's 2 layers of brackets here, right? Compared to this result, there's only 1 layer, right? So that means these results, although they have the same numeric elements in it, but this one has additional dimension. If you look at its shape, it will be 1 by 3, okay? But if you look at this shape, it will be none by 3. It's just 3 elements. It's a 1-dimensional vector, but this one is a 2-dimensional vector. Okay, these are sometimes useful tricks in Numpy because sometimes you want to make the dimensions match. Okay. Oh yeah, I have shown it here. Yeah, the difference is like this. All right, let's go to the next slide. Oops. All right, so that's some even higher dimensions example. You can have a 3-dimensional vector by defining using the ones, like you can have a 3 by 4 by 5. It's basically a cube. And so if you plot it, if you print it, it will be like this. It's like 3 blocks. And in each block, it will be a 4 by 5 of all ones. Okay. So you can use the sum 2 to sum up over over the third dimension, right? Which is axis equals 2. So this is the example that mentioned in the previous question. Okay. Next. All right. So another function, random numbers. It's often used in Numpy. So the 2 options here. The first, rand without n. That means without the n is for normal distribution. So without n, it means a uniform distribution. And for n, for rand n, it's a normal distribution. So for normal distribution with default values 0 and the default variance 1, so it may have a chance to go go beyond range of 1 and the -1, right? But for the uniform distribution, it's strictly within the scope of 0 and 1. So these are the functions that will be used in the future. Oops. Yeah, now let's come to the linear algebra supports. Okay, these are the mostly commonly used functions in Numpy throughout this whole course. So the dots, this dots function, it computes the dot product between vectors. Okay, for the concept of dot product between vectors, I would recommend you to refer to a linear algebra textbook or linear algebra, basic linear algebra definitions online in Wikipedia or wherever you can find the definition. So basically, it is a product between vectors. Okay, so for example, I define two vectors. The first one is 1, 2, 3. Second one is 2, 3, 4. And the dot product between these two vectors is basically 1 times 2 plus 2 times 3 plus 3 times 4. Okay.
And remind me, can you only do dot products of two vectors that are the same dimension? Like they can't have one that's 4 and one that has a length of 3?
That will give you an error if you call the dot product between two vectors that doesn't match the dimensions. Yeah, yeah. So that's the efficient implementation for dot products. And also, if you check out if you directly call A times B, that will give you an interesting result for a pointwise production, for pointwise multiplication, right? If you use A times B, it will basically give you return a vector that is also has 3 elements, but each element is the product of the corresponding dimension. Yeah. Yeah. Dots and pointwise. That's also the operations that we will refer to a lot when we talk about linear regression and the logistic regression models in our next lecture. Okay. And matrix. So the concept of matrix in Numpy, I think it's not that different from a high dimensional ND array. So it's just a ND array that has rows and columns. Okay, so the special syntax in Numpy that supports matrix is a .t, which is the transpose. So it will convert for example, 3x4 matrix to a 4x3. Okay, and sometimes you will need that transpose before you can compute some dot product. So the dot product helps you compute the matrix multiplications. So you can compute the matrix multiplication between a 4x3 and a 3x4. Okay, but the dimensions need to match. Okay, you cannot compute the matrix multiplication between a 4x3 and a 4x5, for example, because the dimensions doesn't match. Okay, we will come to that later before we introduce very specific programming assignments in the future. Oops. Yeah, I think that's the last slide. And I'd like to mention the assignments. I will release it today, and I will give you almost 2 weeks on that. So not less than 2 weeks. So the due date would be next Friday. Actually, next Saturday midnight. So that is what I usually do. What I usually did for the assignments deadlines. Oh, sorry. It should be Friday midnight. No, I'm sorry. I won't accept waitlist students. The class is already big, and sorry about that.
Let me just clarify. So you mean that's February 5th? Or is it this Friday?
No, not this Friday.
Yeah,
It's
so then February 5th.
February 5th,
Okay.
yes, yes. All right, so some question about normalized function. That's a very high level advanced question because the normalized function can refer to a lot of different concepts. In Numpy, we usually, if you want to normalize a vector, say you've got data, you want to make it centered around some mean values and with standard deviations subtracted to each item, you need to do that manually within 0 and 1. It's like a Z transformation, standardized Z transformation. I think some package in SciPy support that, but we really do that manually. Yeah. Someone mentioned PyTorch. So in this lecture for this week's assignments, we don't use PyTorch. So PyTorch is machine learning frameworks that integrate pretty well with Numpy. It can take Numpy datasets as inputs and builds supports the exportation to Numpy data outputs as well. But the main function for PyTorch is to provide easy ways of handling the training process, to handling the gradients, updates the parameters, and so on. But these are all the functions that we will introduce in the future lecture, but not in the first programming setup lecture. Yeah. Thanks for bringing that to the topic.
Will there be a quiz regarding this lecture? And if so, when is the due date on it?
Let me see. No, on Canvas, I don't have quiz for this lecture today. I only have assignments, which is due February 5th.
How frequently are you expecting to have quizzes then?
So like, for example, in the next class, after we talk about linear regression model, I will have a quiz.
Okay.
Actually more than one quiz. But the quiz question is usually small and
Right.
short. Yeah. So it's like basically after each video lecture, I would have a quiz question.
Okay, so this is an atypical week, and most weeks we will have quizzes following them.
Yes.
Okay, cool, thanks.
Yeah, and for today we don't have quiz. I will release the assignments later. All right. Any other questions? All right, good. Okay, so I think I will end the class today, and I'll be happy to answer your questions. You can email me, and also any questions about the TA office hour. I'm still working with our TA, and we'll make announcements soon after we have decided. All right. Let me stop the recording here, and I'll